Hey there, welcome. Tonight, I want to take you on a journey through time and space, where we'll explore the ultimate fate of our very own sun, the bright heart of our solar system. Have you ever wondered what will happen when that mighty ball of fire, which has been shining in the sky for over 4.5 billion years, finally burns out? What will become of Earth and everything we've come to know and love? It's a story that starts billions of years from now, but it's worth thinking about, because even though it seems distant, it's the natural course of things. Let's dive in. To understand what happens when the sun dies, we need to start by looking at its life cycle. You see, the sun, just like all stars, is a giant nuclear furnace. At its core, hydrogen atoms fuse together to form helium, a process that releases an incredible amount of energy that we feel as sunlight. This nuclear fusion has been going on for billions of years, and it's the reason life on Earth exists. Without the sun, life as we know it would not be possible. The sun's warmth is what keeps the Earth habitable, and its light fuels everything from photosynthesis to the weather systems that sustain life. It's not just a star, it's the cornerstone of our existence. But, like everything else in the universe, the sun is not eternal. Just like a candle burning down, it will eventually run out of fuel. The sun is currently in a stable phase of its life, a phase that's known as the main sequence. This stage is the longest and most stable part of a star's life, lasting around 10 billion years. Right now, the sun is about halfway through that stage. The hydrogen in its core is steadily being converted into helium, and this process is what has kept the sun shining for so long. But this process won't last forever. In about 5 billion years, the sun will run out of hydrogen fuel in its core. When that happens, gravity will begin to take over. Without the pressure from the nuclear fusion pushing outward, the core of the sun will contract. As the core contracts, it will get hotter and denser, while the outer layers will expand. This will be the beginning of the end for the sun as we know it. As the outer layers swell, the sun will become a red giant. It will grow to a size so massive that it could engulf the orbits of Mercury, Venus, and perhaps even Earth itself. Imagine standing on Earth, if you could even stand, as the sun begins to expand. The sky would be painted in brilliant hues of red and orange, and the heat would become unbearable. The Earth's surface would become a barren desert, oceans evaporating into the atmosphere, leaving behind nothing but a scorched, lifeless shell. For life, this would be the end. The sun's transformation into a red giant will strip away the very conditions that have made life possible on Earth. It will be the most dramatic change our planet has ever experienced, and nothing will survive the intense heat. But, in truth, Earth might not even make it that far. As the sun grows, it will expand outward, and its atmosphere will become so vast that it could potentially reach Earth's orbit. If that happens, the planet will be swallowed up by the sun's outer layers. If Earth is spared from being consumed, the increase in temperature will still make the planet uninhabitable. Life on Earth will be impossible long before the sun physically engulfs the planet. Oceans will evaporate, the atmosphere will dissipate, and the Earth will become a dry, lifeless rock floating aimlessly in space. This transformation of the sun into a red giant will not be a sudden event. It will happen slowly, taking place over millions of years. It's a gradual process, but every step of it will be catastrophic. In the final stages of the sun's life, it will shed its outer layers into space, creating what is known as a planetary nebula. This will be an enormous cloud of gas and dust, a stunningly beautiful spectacle of light and color, visible across the cosmos. But even as this nebula forms, the sun itself will be dying. It will no longer be a blazing ball of fire, but a cooling, shrinking remnant of its former self. In the core of the nebula will remain the heart of the sun, a small, dense object called a white dwarf. A white dwarf is a star that has exhausted its nuclear fuel and no longer undergoes fusion. It's essentially the exposed core of the sun, a faint, slowly cooling ember. Over billions of years, this white dwarf will continue to cool and fade, becoming darker and darker, until it no longer emits any light at all. This is the final fate of our sun. It will slowly become a black dwarf, a cold, dark, lifeless object. And with it, The solar system will enter a new phase, a silent, frozen void. It's a future so far away that it seems almost impossible to comprehend. But it's the inevitable destiny of every star, including the one that gives us life. For now, though, the sun is still shining brightly, and we can only imagine what it will be like when that final chapter comes to pass. And as we look up at the sun today, we might wonder, how will it affect not just the Earth, but the other planets in the solar system? Let's take a moment to think about that. What happens to the other planets when the sun turns into a red giant? Will they survive the sun's fiery transformation? Will any of them remain untouched by the sun's expansion? That's what we'll explore next, as we turn our attention to the planets, their fates, and how they will be forever altered by the sun's death. When the hydrogen in the sun's core is depleted, it will mark the beginning of the sun's final stages, a dramatic transformation that will not only change the star itself, but also everything around it. This process won't be immediate, but it will unfold over billions of years. As the hydrogen runs out, the sun's core will begin to contract under the force of gravity, causing its outer layers to expand. The sun will turn into a red giant, growing to such enormous proportions that its outer layers will engulf nearby planets, including Mercury and Venus. As the sun expands, its size will increase by about 100 times. The temperature in its outer layers will start to decrease, but this will not be the end of the story. This phase will last for several 100 million years, during which the sun will continue its destructive path. It will be a time of colossal change. The Earth, most likely, will not survive this phase. As the sun expands, the temperature on Earth will increase dramatically, causing the oceans to evaporate and the atmosphere to be stripped away. Life as we know it will be impossible. The Earth could either be swallowed by the expanding sun or become a barren wasteland where no life can exist. Oceans will boil away, and the surface will become a molten desert. Even if Earth somehow escapes the sun's direct reach, the intense heat will still make the planet uninhabitable. The process will be slow, but inevitable. The sun's transformation into a red giant will fundamentally alter the solar system. Not just Earth, but the orbits of all the planets will be affected. As the sun swells, its gravity will start to pull the planets closer. Even Mars, which is farther away, will face extreme heat, while the gas giants like Jupiter and Saturn may experience shifts in their positions and orbits. But the true tragedy of this phase lies in the fate of Earth. The once thriving planet, full of life, will be turned into a lifeless shell, a testament to the sun's power. In those final moments, the Earth might resemble a dead world, a ghost of the planet we once knew. And though we will not be around to witness it, this moment will mark the end of our world in a way that no disaster on Earth could ever match. The sun's transformation into a red giant will signal the end of an era, not just for Earth, but for everything within the reach of its fiery grasp. But the story doesn't end there. Even after the sun reaches its peak size, it won't stay in the red giant phase forever. In fact, this stage will only be a temporary one. The energy produced from the fusion of helium will not be enough to sustain the sun for much longer. Soon, the sun will shed its outer layers, creating a stunning, colourful nebula in space, the remains of what was once a mighty star. This process of shedding its outer layers will lead to the formation of what's known as a planetary nebula. It will be a cloud of gas and dust, spreading out into space, lighting up the sky with brilliant colours. This nebula will drift through the cosmos, a reminder of the sun's former glory. Meanwhile, at its centre, the sun's core will become a small, dense remnant known as a white dwarf. The transition from a red giant to a white dwarf marks the sun's final stage. It will no longer shine as brightly as it once did, but will instead fade, cooling over the next several billion years, until it becomes a cold, dark, and lifeless object known as a black dwarf. This is the sun's ultimate fate. It's a slow death, but one that will take billions of years to unfold. And as this happens, it will completely reshape the solar system. But what about the planets? Will they survive the sun's death throes? How will the other planets, moons, and objects in the solar system be affected by this cosmic transformation? This is what we'll explore next as we look at the fate of the planets and their future under the red giant sun. As the sun exhausts its supply of helium in the core, it will no longer have the fuel needed to sustain the nuclear reactions that keep it stable. Without the energy produced by these reactions, the sun will begin to lose its balance. The gravitational force, which once had been counteracted by the outward pressure from fusion, will now cause the sun to collapse in on itself. As the core contracts, the outer layers will expand even more, and the sun will become increasingly unstable. In this state of instability, the sun will begin to shed its outer layers into space. This will not happen suddenly, but gradually, as the sun's outer envelope of gases and dust is ejected, forming what is known as a planetary nebula. The term planetary nebula is actually a bit of a misnomer, as these nebulae have nothing to do with planets. They are instead vast clouds of gas and dust that are the remnants of a dying star. Over the course of about 10,000 years, the sun will lose its outer layers, sending them out into space in a dramatic, yet beautiful display. These layers will expand outward, forming a massive glowing cloud that will slowly spread and dissipate over time. The colors of the planetary nebula will vary depending on the elements in the sun's outer layers. The gases will glow in shades of blue, green, red, and violet, creating a spectacle of light that would be visible from far across the galaxy. These nebulae are often some of the most beautiful objects in space, but they are also fleeting, a cosmic death knell for the star that created them. At the center of this nebula, however, the sun will leave behind a remnant, a white dwarf. This white dwarf will be a small, dense, incredibly hot object, roughly the size of Earth, but with a mass comparable to the sun. It will no longer undergo fusion reactions, meaning it will no longer produce energy in the way it once did. Instead, the white dwarf will simply be a remnant of the sun's core, slowly cooling and fading over billions of years. The white dwarf will not be a stable, shining beacon like the sun was. Over the course of time, it will begin to lose its heat and light. Unlike a regular star, it will not have the fuel necessary to start new fusion reactions. It will radiate heat for a while, but eventually it will become a cold, dark, and silent object. This process will take billions of years, but eventually the white dwarf will cool to the point where it no longer emits any light at all. At that point, it will become a black dwarf, a lifeless, dark, and frozen remnant of the sun, quietly drifting through space. In essence, the once mighty star that gave birth to life in the solar system will end its existence in total darkness. The bright, warm center of the solar system will become nothing more than a shadow of its former self, a tiny, cold speck in the vastness of the universe. The transformation of the sun from a vibrant star to a cold, lifeless black dwarf will take an unimaginable amount of time, billions of years, far beyond the reach of human comprehension. While the sun's death may seem distant and unimaginable now, its impact on the solar system will be profound. As the sun sheds its outer layers and becomes a white dwarf, the planets will be left to drift in the void. The once comforting warmth of the sun will be gone, and the planets will be left to float in the dark, cold reaches of space. Life on Earth will be long gone by that time, but even if humanity manages to survive and venture to new worlds, the eventual death of the sun will signal the end of everything that exists in the solar system. And as for the other planets, their fate will also be sealed by the sun's transformation. The gas giants like Jupiter and Saturn will continue to orbit the white dwarf, but their once vibrant atmospheres and moons will be changed forever. Their icy moons, like Europa and Titan, might survive the sun's red giant phase, but they will never be the same. Life on these distant worlds may be possible in the far future, but not under the warm rays of the sun. Instead, they will be exposed to the dim, cold light of a white dwarf, a light that will never bring warmth or life. In the end, the sun's death will be a quiet one, not marked by the dramatic flare of a supernova, but by the slow, almost imperceptible fading of a once mighty star. Its final gift to the solar system will be the beauty of the planetary nebula it creates before it disappears, leaving behind only a white dwarf, slowly cooling in the vastness of space. As the sun transforms into a red giant, It will not only change itself, but will also bring about radical shifts across the entire solar system. The fate of each planet, each moon, and even the smaller objects in our cosmic neighborhood will be determined by the sun's evolution. Some will endure, others will be altered beyond recognition. Earth for Earth, this period will be catastrophic. As the sun expands, the temperature on the planet will rise beyond anything Earth has ever experienced. The polar ice caps will melt, and the oceans will slowly evaporate into the atmosphere, transforming the planet into a parched, desolate world. The Earth's atmosphere will be stripped away by the intense solar wind, leaving the planet exposed to the harsh vacuum of space, no longer protected by the greenhouse gases and the oxygen-rich atmosphere we rely on. Earth will become a barren, lifeless rock. Even if Earth doesn't get engulfed by the expanding sun, it will be uninhabitable long before that. The once fertile world will be reduced to a sun-baked husk, with no water, no atmosphere, and no life. The destruction of life on Earth will mark the end of an era for the planet. Once teeming with life, Earth will become a silent reminder of the fragility of existence in the universe. It's hard to imagine such an end for our home, but it is the inevitable future. A planet once lush and vibrant, turned into a dead, scorched wasteland. Mars, already a cold and inhospitable world, will face its own set of challenges as the sun begins to die. Although the red planet is far enough away from the sun to avoid being engulfed by the expanding red giant, it will still undergo drastic changes. The already thin Martian atmosphere will continue to thin and dissipate under the sun's increasing radiation. Mars will become even colder, its once weak atmosphere unable to shield it from the growing solar intensity. However, there might be a small glimmer of hope during the sun's red giant phase. In rare moments, Mars could find itself in a zone where the sun's increased radiation might temporarily warm the planet enough for microbes or simple forms of life to survive. Perhaps even humanity, if we manage to establish a colony on Mars before this transformation, could find ways to adapt to the changing environment. While life on Mars today seems impossible, the idea of transforming the red planet into a new Earth through advanced terraforming technologies remains a topic of scientific speculation. As Mars enters the habitable zone during the red giant phase, it might become the most promising candidate for colonization. But only if we can overcome the planet's extreme cold and thin atmosphere. It's an exciting thought, but one that hinges on how much time we have left before the sun's transformation makes even Mars uninhabitable. Jupiter and its moons Jupiter, the largest planet in the solar system, will continue to dominate the outer regions of our cosmic neighborhood. But even the gas giant will not be immune to the changes brought by the sun's evolution. As the sun expands and its mass causes changes in the solar system's gravitational balance, Jupiter may experience subtle shifts in its orbit. The planet will likely remain in its current position, but its moons and rings will face significant changes. Jupiter's moons, like Europa and Ganymede, will experience increasingly harsh conditions as the sun grows. Europa, however, stands out as one of the most intriguing places for future exploration. Beneath its thick icy crust, Europa harbors a subsurface ocean that could potentially support life. As the sun expands and radiates more heat, this ocean may become more accessible to probes or even future human exploration. If there is life in Europa's deep, dark waters, it would survive in the extreme conditions found under the ice, far away from the sun's heat and light. The idea that Europa could harbor alien life makes it one of the most exciting places to search for extraterrestrial organisms. The moons of Jupiter, such as Io and Callisto, will also face extreme shifts. Io, with its active volcanic surface, may find its volcanic activity altered as it experiences gravitational forces from Jupiter's shifting orbit. Meanwhile, Callisto's surface, already a frozen wasteland, may become even more inhospitable as the sun's heat reaches the outer solar system. But Europa, with its hidden ocean, may very well remain a beacon of hope in the distant future for discovering life in the most extreme environments. It's a tantalizing possibility that one day, far in the future, humanity could visit Europa in search of signs of life beneath the ice. Saturn and Titan. Saturn, and its magnificent rings will continue to be one of the most recognizable features of the outer solar system. Despite being far from the Sun, Saturn will still be affected by the Sun's transformation. As the red giant phase causes massive changes in the solar system's gravitational interactions, Saturn's moons, including its largest and most famous moon, Titan, will feel the effects. Titan, with its thick nitrogen atmosphere and icy surface, might not survive the extreme conditions of the Sun's final stages. However, Titan's dense atmosphere and the possibility of liquid methane seas on its surface make it one of the most fascinating objects in the solar system. If humanity ever develops the technology to survive on such an exotic, cold world, Titan could become a candidate for future colonization. In the distant future, if we can find ways to adapt to its freezing temperatures and strange chemistry, Titan could provide an environment for humans to live, though it would be a life quite different from anything we know on Earth. As the Sun evolves, Saturn's moons, along with Titan, will continue to orbit the dying star. Their fate will depend on the interactions between the expanding Sun and the gravitational forces within the outer solar system. Some moons may be drawn closer to Saturn, others could be flung out into space. As the outer planets and their moons feel the gravitational tug of the expanding Sun, the once stable orbits of these icy worlds will become increasingly chaotic. In time, Titan and the other outer moons will be left to drift in the dying glow of the white dwarf Sun, their futures uncertain but likely cold and barren. Still, the strange beauty of Titan's icy world and its potential for harboring life in some form will continue to fascinate scientists and explorers for centuries to come. Uranus and Neptune, the two most distant gas giants in our solar system, will also feel the effects of the Sun's transformation into a red giant. These icy planets, already far from the Sun's heat, will become even colder as the Sun's radiation weakens and the solar system's environment changes dramatically. While these planets are far from the Sun and less likely to be affected directly by the Sun's expansion, their moons may still experience significant changes. Uranus, with its tilted axis and strange, frozen atmosphere, may undergo some changes in its own orbit or interactions with other objects in the outer solar system. Neptune, too, will experience these same changes, but the larger issue for both planets will be the gradual cooling and eventual disappearance of sunlight. The moons of these planets, like Triton for Neptune and Miranda, or Titania for Uranus, could face extreme conditions. Triton, Neptune's largest moon, is one of the most fascinating objects in the outer solar system. It is the only large moon in the solar system with a retrograde orbit, suggesting it may have been captured by Neptune's gravity in the distant past. Triton is also geologically active, with geysers of nitrogen gas and a surface dotted with frozen plains. However, as the Sun's energy fades, Triton's already frigid environment will become even more inhospitable. Whether there is any chance for life or future exploration will depend on how well we can adapt to such extreme environments. The outer solar system and the Kuiper belt, beyond the planets themselves, the outer reaches of the solar system, the Kuiper belt and Oort cloud, will also be affected by the Sun's changes. The Kuiper belt, a vast region filled with icy bodies like Pluto, Haumea, and Eris, will feel the effects of a cooling Sun. These objects, once warmed by the Sun's radiation, will continue to drift further into the cold, dark expanse of space as the Sun's warmth fades. The Oort cloud, a vast spherical region surrounding the solar system at an even greater distance, is home to trillions of icy bodies that may one day become comets. As the Sun dies, these icy bodies will continue their slow, solitary orbits, far from the remnants of the once luminous star. With the Sun becoming a white dwarf and no longer emitting significant heat, these far-flung objects will be cast into an eternal darkness, isolated from the fading warmth of the solar system's center. In this far-flung region of space, only the faintest remnants of the solar system will remain. The Oort cloud will be a cold, silent region, populated only by frozen objects that are too distant to interact with anything else. As the Sun's light and warmth fade, the once vibrant outskirts of our solar system will become a cold, quiet, and barren place. The fate of the solar system, ultimately, the Sun's death, will bring about the complete transformation of the entire solar system. As the Sun enters its final phase as a white dwarf, its gravitational influence will continue to shape the orbits of the planets and moons, but the once familiar warmth and light will be gone. The gas giants will continue to orbit the white dwarf, their moons and rings cold and distant, while the rocky inner planets will have long since been destroyed or reduced to barren wastelands. The solar system, as we know it, will become a shadow of its former self. The once vibrant, life-sustaining center of the system, the Sun, will no longer shine, and all that will remain is a cold, lifeless remnant. The gas giants, icy moons, and distant objects like the Kuiper Belt and Oort cloud will drift endlessly through the dark, cold void, their futures uncertain. Life, if it still exists in the outer reaches of space, will be entirely disconnected from the solar system's dying star. If humanity, or other life forms, manage to survive by migrating to other star systems or colonies, the solar system will be a distant memory, a dead remnant of a once thriving neighborhood of life and energy. And as we look to the future, the question remains: what will happen to the remnants of the Sun, the white dwarf and the slowly fading planetary nebula? Will it simply drift in the void, forever, a relic of the past, or will it eventually be consumed by the gravitational forces of another star, or even a black hole? As the solar system fades into the cold, dark reaches of space, humanity, if it survives, will continue its journey into the unknown. The death of the Sun will be the end of an era, but the story of the universe, and our place in it, will continue, stretching far beyond the reach of the fading remnants of the once brilliant star. Once the Sun exhausts its fuel and transitions into a white dwarf, the solar system will undergo a dramatic transformation. With no more energy being emitted by the once vibrant star, the entire system will plunge into a deep, unrelenting cosmic cold. The warmth that had sustained life on Earth and provided the energy for all the planets will vanish. The Sun's gravity will continue to exert its pull on the planets. The planets will no longer be bathed in the comforting light and warmth that once gave them life. The Earth's final fate for Earth, the absence of the Sun's warmth, will mean the end of life as we know it. Without the Sun's heat, Earth's surface temperature will plummet to unimaginable lows. The oceans, which were once vast and teeming with life, will freeze over, leaving behind a lifeless, frozen world. The atmosphere, which had once protected life from the harshness of space, will dissipate into the void, leaving Earth exposed to the cold, empty vacuum of space. The once fertile planet will become a lifeless, frozen rock drifting in the dark reaches of the cosmos. Even if some form of life, perhaps deep beneath the frozen surface or in isolated pockets, survives for a time, the Earth will eventually become a silent, desolate planet, its once thriving ecosystems and biospheres lost to time. The world will spin endlessly, a cold, barren object with no warmth, no atmosphere, and no life. The outer planets, while the inner planets like Earth and Mars will feel the absence of the Sun's warmth most acutely, the outer planets will not escape their own fate. The gas giants, Jupiter, Saturn, Uranus, and Neptune, will continue to orbit the white dwarf, but their moons, which were once warmed by the Sun's light, will become icy, cold worlds. The once active surfaces of moons like Europa and Titan, which have been heated by tidal forces and perhaps by the Sun's warmth, will grow even colder. These moons, though still holding on to some degree of heat from their internal processes, will now face extreme cold, leaving them less hospitable for any remaining life or future colonization. Jupiter, Saturn, and their moons will continue their slow, unchanging orbits around the white dwarf, but the once stunning sights of Saturn's rings and the swirling storms of Jupiter will become distant memories. The planets themselves, however, will continue their journey through space, though with none of the life, giving energy that once drove their dynamics. The slow drift of the solar system, now bereft of its primary source of light and heat, will continue to exist, but it will be a shadow of its former self. The planets will still orbit the white dwarf, but those orbits will slowly change over time. The gravitational pull of other stars, drifting through the interstellar void, will begin to affect the paths of the planets, perhaps pulling them into new trajectories. The once stable orbits will begin to destabilize, and as the white dwarf cools and loses its gravitational influence, the planets may start to drift farther from their once sun. The distance between the planets and the remnants of the sun will slowly increase. The gravitational grip of the white dwarf, though still powerful, will not be as forceful as that of a live, active star. The planets will begin to move further and further away, becoming increasingly isolated, drifting through the cold vacuum of space. The solar system will slowly lose its cohesion, and over an incredibly long period of time, the planets and moons could eventually break free from their orbits, becoming wanderers in the interstellar void. The remaining energy sources, despite the loss of the sun, the solar system will still hold some residual energy in the form of tidal forces, gravitational interactions, and potentially the faint glow of distant stars. For example, moons like Europa or Titan could still hold on to some heat from their internal processes. The tidal interactions between moons and their parent planets could provide some level of warmth. Europa, for example, may still have its subsurface ocean, kept warm by tidal friction from Jupiter's gravitational pull. But without the sun, these systems would eventually cool and fade, and any remnants of life would be forced to adapt to an entirely new and harsh environment. Beyond this, the most significant source of energy for the solar system will be the cold, dark interstellar medium. Without the sun's light to illuminate the vastness of space, the solar system will become a dim, dark corner of the galaxy, surrounded by the infinite vastness of the universe. Cosmic isolation. In this new era, the solar system will become isolated from the rest of the galaxy. The bright, shining star that once anchored the system to the Milky Way will have faded, and its remnants, the white dwarf, will become just another faint, distant point of light in the cold vacuum of space. The planets and moons, once connected by the life, giving warmth of the sun, will now be drifting apart, isolated in the blackness of the universe. The gravitational influence of other stars and objects will slowly reshape the orbits of the solar system's bodies. But without a guiding force like the sun, the system will become more and more fractured. The once strong bonds between the planets and the sun will dissolve, and eventually, the planets will no longer be tethered to a single source of energy. The system will exist in a state of quiet isolation, with no central warmth or energy source to hold it together. The end of an era as the eons pass, and the solar system fades into the cold darkness of space. It will become a distant memory, a forgotten chapter in the history of the galaxy. The once vibrant and active system, full of life and energy, will have become a quiet, empty place, devoid of the light that once brought it to life. The stars will continue their cycles of birth, evolution, and death, as they have for billions of years. But the solar system, our home, will be a long, forgotten relic of the past, a cosmic tomb in the endless void. In this final stage, the solar system will cease to be a place of life, exploration, and hope. It will simply be a collection of cold, lifeless objects, drifting forever through the interstellar medium, forever apart from the galaxy's bright stars. The energy that once bound it together, the energy of the sun, will be no more, and all that will remain is the eerie, eternal quiet of a star that has burned out. But even in this state of cosmic cold, life elsewhere in the universe may continue. New stars will rise, new worlds will form, and perhaps even new forms of life will evolve on other planets. The universe will continue to unfold, as it always has, moving through time and space, constantly changing, never stopping. The story of the solar system, of Earth, of life, and of the sun, may one day be forgotten, but the vast, timeless dance of the cosmos will continue, stretching into the unfathomable future. As the sun begins to fade, and the future of the solar system becomes a cold, dark reality, the question arises: can humanity survive? We are used to thinking of Earth as the cradle of humanity, the place where we have evolved and thrived for millions of years. But with the inevitable end of the sun, the idea of living beyond our home planet begins to seem less like science fiction and more like a necessity. Humanity's survival, in the long run, will depend on our ability to adapt, to move beyond the confines of Earth, and to find new homes among the stars. Leaving the solar system a far-off dream. Leaving the solar system may sound like a distant, almost impossible task. After all, the distances between stars are mind-boggling. The closest star to our solar system, Proxima Centauri, is over 4 light-years away. This means that even with the fastest spacecraft we have today, it would take tens of thousands of years to reach just one neighboring star. And that's only if we were to send a probe or unmanned ship far beyond the capabilities of human travel with our current technology. However, the future might hold solutions we can't yet fully comprehend. Humanity has always been a species that adapts and innovates. We've gone from walking on the moon to developing the technology to send probes to the outer reaches of the solar system. There is every reason to believe that we may one day figure out how to travel at a significant fraction of the speed of light, a breakthrough that would drastically reduce travel times between stars and make interstellar colonization possible. Colonizing new worlds, Mars and beyond. One of the most talked about possibilities for human survival outside Earth is colonizing Mars. With its relatively similar day-night cycle and evidence of ancient water, Mars offers a tantalizing opportunity to establish a new home. Space agencies around the world, like NASA and private companies like SpaceX, are working hard to develop the technologies necessary for human missions to Mars. The creation of self-sustaining colonies on Mars would require advanced life, support systems, radiation protection, and the ability to grow food in the planet's thin, cold atmosphere. Mars may be the first stop on humanity's journey to the stars. But the challenges of living on a barren world, with no breathable atmosphere and little natural protection from cosmic radiation, make it far from an ideal choice for long-term survival. Even if we do manage to establish a foothold on Mars, it's unlikely to be a permanent refuge. Eventually, the harsh conditions and limited resources would make survival difficult. Mars, with all its potential, may still be a temporary stepping stone for humanity, not a long-term home. Titan and the moons of Jupiter, cold havens for life. If Mars proves to be less hospitable than we hope, the next targets for colonization might be the moons of Jupiter and Saturn. Titan, Saturn's largest moon, is an intriguing possibility. Despite its cold, methane-rich atmosphere and surface temperatures well below freezing, Titan presents some unique advantages. It has an atmosphere, something that Mars lacks, and it also has a rich organic chemistry that could potentially support life. Titan's thick atmosphere could provide some protection from cosmic radiation, and its surface could serve as a base for human settlements, though advanced technologies would be needed to make it habitable. The challenge of surviving on Titan, however, is that its surface is an incredibly hostile environment. The moon's frigid temperatures and lack of breathable oxygen would require closed habitats, and the thick methane clouds in the atmosphere would make it hard to see the sun, adding to the difficulty of growing food. Then there are the moons of Jupiter, such as Europa, where liquid water may exist beneath a thick ice shell. While Europa is an icy world, the potential for subsurface oceans, heated by tidal forces from Jupiter's gravitational pull, has made it an object of fascination. If we can find a way to drill through the icy surface and access these hidden water reserves, Europa could offer a refuge for humanity in the future. But again, like Titan, the harsh conditions on these moons would require humanity to develop entirely new technologies for survival. Technological advancements and the promise of artificial habitats. As we look beyond our solar system, one of the most promising ways for humanity to survive could lie in the creation of artificial habitats. These space stations, biodomes, or even self-sustaining spaceships would allow humans to live independently of any planet or moon. In the distant future, we may build massive, self-sustaining cities that could house millions, even billions, of people floating in the vast expanse of space. These colonies could be built around artificial suns, fusion reactors, or other energy sources that provide light and warmth, and with advanced life support systems, they could be fully self-sufficient. These artificial worlds would be independent of any planetary system, offering a unique form of survival in the face of a dying sun. The key to this survival would be the ability to create a completely closed-loop system where resources like air, water, and food could be recycled indefinitely. To build such habitats, however, humanity would need to solve some of the most complex problems of space colonization, including how to generate enough energy, how to create sustainable agriculture in space, and how to protect against the deadly radiation that fills the vast emptiness of space. Interstellar travel, reaching new star systems, once humanity has mastered the art of colonization within our own solar system, we will likely need to venture beyond it, into the vast unknown of interstellar space. The idea of reaching another star system, such as Alpha Centauri, has been a subject of scientific inquiry for decades. But how could we make such a journey possible? One possibility is the development of fusion-powered spacecraft or even antimatter propulsion, concepts that could theoretically push spacecraft to a significant fraction of the speed of light. If we could develop such technologies, a trip to a nearby star system could take just a few decades, rather than the thousands of years it would take with current technology. This kind of technology would allow humanity to not just escape the death of our own sun, but to spread out across the galaxy, establishing new colonies around distant stars. Can humanity survive the end of the sun? While it may seem like an insurmountable challenge, there's reason to believe that humanity could survive the end of the sun if we act now. The journey to escape the sun's death will require us to develop entirely new technologies, to think beyond our planet and our solar system, and to prepare for the most extreme conditions. We may not have all the answers yet, but we've come a long way since the first steps on the moon. If we continue to push the boundaries of exploration and innovation, the future could hold a place for humanity among the stars. Surviving the death of the sun may not be possible in the near future, but with the right vision and technology, humanity could one day achieve the impossible. The challenges will be great, but they are not insurmountable. And who knows? Perhaps, in the distant future, we will look back on the extinction of our sun not as the end, but as the beginning of our journey to the stars. As humanity looks to the distant future, the quest to survive the death of the sun is more than just a theoretical pursuit. It's a challenge that calls for innovation, resilience, and perhaps even a reimagining of what it means to be human. The idea of traveling to new star systems and establishing colonies on distant worlds will require an evolution in both our technology and our thinking. The long journey to a new home among the stars is not just a matter of getting there. It's about sustaining life during the journey and ensuring that future generations can thrive in an entirely new environment. For the first time in human history, we may need to think beyond the comfort of our earthly home and focus on building entirely new ecosystems in space. Living in deep space. The challenges of interstellar travel, traveling across vast interstellar distances, presents unprecedented challenges. Current spacecraft travel at speeds that would take tens of thousands of years to reach even the nearest stars. To shorten this journey, we must develop advanced propulsion systems that can push spacecraft to a significant fraction of the speed of light. One promising concept is nuclear fusion propulsion, where a spacecraft would harness the energy from fusing hydrogen atoms, a process that powers the sun itself. If we could build such a system, it would provide the continuous, immense thrust needed to reach faraway star systems within a human lifetime. However, the technological and material hurdles to make this a reality are enormous. The spacecraft would need to withstand incredible heat and radiation, while still maintaining the delicate balance of life support systems for its crew. Another fascinating possibility is light sail technology, where a spacecraft is propelled by laser beams or concentrated sunlight, creating immense speeds without traditional fuel. With this technology, we could, in theory, send a spacecraft to other stars in a matter of decades, not centuries. Still, the challenge of sustaining life during such a journey, possibly spanning generations, is one of the biggest obstacles. Generational ships. A sustaining future, one of the most practical, albeit difficult, solutions to interstellar travel is the idea of a generational ship. These colossal, self-sustaining spaceships would house entire populations and travel slowly across the vast emptiness of space. The ship would need to have its own closed-loop systems, capable of recycling air, water, and food. People born on these ships would live their entire lives in space, their descendants continuing the journey for many generations. By the time the first crew reaches a new star system, their descendants might be the ones to settle there, continuing the human story far from Earth. But even the concept of a generational ship comes with its challenges. It's not just about having the technology to maintain life in space. It's about creating a society that can thrive in such isolated conditions. The psychological strain of living in confined spaces for generations, combined with the lack of new horizons or natural landscapes, could create an environment where mental health becomes a major concern. Social systems, governance, and relationships would need to evolve in ways that we can hardly imagine today. The search for habitable worlds. Once humanity has developed the means to travel across the stars, the next challenge is to find a place to call home. The search for habitable planets or moons will become the focal point of interstellar colonization. The question is, how do we find a world that can support life as we know it? What makes a planet habitable? To answer these questions, we must rely on the tools of modern astronomy. Exoplanet discovery. The search for planets orbiting stars outside our solar system has already yielded thousands of candidates. However, finding planets that are truly habitable, that is, planets with liquid water, a breathable atmosphere, and a stable climate, remains one of the greatest challenges of space exploration. Scientists are beginning to focus on a group of stars called red dwarfs, which are the most common stars in our galaxy. These stars are smaller and cooler than our Sun, but they have longer lifespans, which could allow for more time for life to develop on planets orbiting them. Planets in the habitable zone of these stars, sometimes referred to as the Goldilocks zone, could be just the right temperature to support liquid water. However, even with advanced telescopes, finding Earth-like planets around these stars remains a difficult task. Terraforming, making a new home for humanity. Once a suitable exoplanet is found, the next step is to make it habitable. The concept of terraforming, transforming a planet's environment to make it suitable for human life, has been a subject of fascination for decades. The idea of turning a barren world into a thriving ecosystem capable of sustaining humans is both daunting and exciting. For example, the terraforming of Mars has been a goal of scientists for years. While Mars has some of the building blocks for life, including water ice and carbon dioxide, its atmosphere is too thin and cold to support life. To terraform Mars, we would need to thicken its atmosphere, increase its temperature, and introduce oxygen. This process could take centuries, or even millennia, but it is possible with the right technological advancements. Beyond Mars, moons like Europa or Enceladus, which may harbor subsurface oceans, could be terraformed in the future. However, the challenges of terraforming are immense. It requires an understanding of planetary systems, climate engineering, and the ability to control an entire ecosystem. Such an endeavor would require both technological mastery and a deep understanding of the balance of life on Earth, which we must replicate in these new environments, building a future among the stars. As we look toward the distant future, the possibility of humanity thriving beyond Earth may seem like a dream. But just as humans once dreamed of flying and landing on the moon, we may one day dream of living among the stars. This dream will require incredible advancements in science, technology, and society. It will take generations of effort. But humanity's spirit of exploration and innovation may make it possible to live on distant worlds, creating new homes for future generations. However, as we prepare for the end of the sun and look toward the stars, we must also consider the broader question: what will humanity be like when we live among the stars? The answer may be just as much about who we are as a species as it is about where we live. The challenges of surviving in space, creating sustainable colonies, and adapting to new worlds will undoubtedly shape our evolution. In the end, the journey to the stars may not just be about surviving the death of our sun. It may be about humanity finding a new purpose, a new identity, and a new place in the universe. The sun will die, but humanity's story need not end with it. Instead, it could mark the beginning of a new era of exploration, discovery, and survival. The stars are waiting for us, and they have always been part of our destiny. As humanity embarks on its journey through the stars, we will face challenges that no generation before us has ever had to contend with. These challenges will shape not only the future of our species, but also our legacy in the vastness of the cosmos. What we choose to do as we leave behind Earth will define the very essence of what it means to be human. Becoming a multi-planetary species, if humanity is to survive the inevitable death of the sun, it must evolve from a single planet species to a multi-planetary civilization. This transformation will take time, effort, and ingenuity. Colonizing new worlds, whether they be on Mars, the moons of Jupiter, or distant exoplanets, will not be an easy feat. Every new world will come with its own set of challenges, and humanity will need to adapt to the unique conditions of each. Building sustainable colonies will be the first step, but the bigger challenge will be ensuring that these colonies remain self-sufficient over the long term. Unlike Earth, which has a rich ecosystem and an abundant supply of resources, space colonies will have to rely on closed-loop systems for food, water, and oxygen. These systems will need to be carefully managed and maintained, as even the smallest breakdown could lead to disaster. In the future, terraforming and bioengineering will likely become essential tools for making new worlds habitable. Scientists may develop ways to modify a planet's atmosphere, introduce plant life, or even create entirely new forms of life capable of thriving in alien environments. The ability to engineer ecosystems will be crucial for humanity's survival, but it will also come with ethical considerations. How much should we alter a world to make it fit for human life? What responsibilities do we have to the ecosystems and life forms that may already exist there, even if they're microscopic? The rise of artificial intelligence in space. As humanity ventures further into the unknown, artificial intelligence, AI, will play a key role in helping us navigate the complexities of interstellar travel and colonization. AI systems will be critical in managing the life support systems of spacecraft, controlling energy production, and assisting in the construction of new colonies. These AI systems could also play a pivotal role in decision-making, helping us solve the problems that arise when colonizing new worlds. In addition to AI, robotics will become a cornerstone of space exploration. Robotic construction crews, automated farming systems, and autonomous mining operations could help establish the infrastructure needed for life on distant planets. These machines could do much of the heavy lifting, allowing human settlers to focus on adaptation and thriving in their new environment. Cultural and social evolution in space. As humanity spreads across the stars, its culture and society will inevitably change. Living on different planets and moons will mean that future generations of humans will adapt to different environments, and they will face new challenges and opportunities. The way we think about community, identity, and even human nature will evolve. In space, there will be no singular Earth culture that binds everyone together. Instead, each colony will develop its own unique culture, shaped by its environment and the specific challenges it faces. On a colony on Mars, for example, life might be focused on survival and scientific discovery, with a strong emphasis on cooperation and resource sharing. A colony on Titan, in contrast, might foster a culture of innovation and adaptability, with people developing entirely new technologies to survive in a harsh, frozen world. This divergence in cultures could lead to new forms of governance. The laws, rights, and freedoms that we take for granted on Earth may need to be redefined in the context of space colonies. New ethical dilemmas will arise. How should resources be shared? What rights should settlers on Mars or Europa have? How should colonies on different planets relate to each other? As we venture into the stars, humanity will be forced to rethink its very concept of society. The philosophical implications of life in space Living in space will also raise profound philosophical questions about the meaning of life and humanity's place in the universe. Away from the familiar shores of Earth, the perspective of life on a distant planet or moon may force us to reconsider our relationship with the cosmos. As we look up at distant stars, we will see not just distant lights, but potential futures. Our ancestors looked up at the sky with awe and wonder, thinking of the divine or the unknowable. In space, we may feel the same sense of awe, but with the added responsibility of knowing that the stars are no longer distant. They are potential homes, places where humanity can thrive. The isolation of space may also prompt a search for meaning in new ways. With the sun gone and Earth a distant memory, we may look to the stars not just for survival, but for a new sense of purpose. Will humanity become a species of explorers and settlers, spreading our civilization to distant planets? Will we continue to search for knowledge and understanding, seeking to understand our origins and place in the universe? In the end, the journey into space will not just be a physical one, it will be a deeply spiritual and existential journey. The pursuit of knowledge, the search for new frontiers, and the desire to survive may all be driven by a fundamental human need to find meaning, purpose, and connection, even in the cold vastness of space. The cosmic legacy of humanity. As we venture deeper into the stars, one thing becomes clear: humanity's legacy will not be defined by the death of the sun, but by the lives we create in the void. Just as our ancestors left their mark on Earth, we will leave our mark on the galaxies. We will leave behind a trail of exploration, technology, art, and culture. Future civilizations, whether they are human or something else, will look to our journey with awe and wonder. They may discover the remnants of our colonization efforts, our ruins on far-off moons, and perhaps even the genetic markers of human life spread across the stars. In this sense, the death of the sun may not mark the end of humanity, but the beginning of a new chapter, one in which our species will continue to evolve, adapt, and thrive in the vastness of space. Our legacy will be one of survival, exploration, and ultimately, the understanding that we are not just creatures of Earth. We are creatures of the universe, with the potential to carve out a future among the stars. As we stand on the precipice of an uncertain future, the death of our sun represents both a challenge and an opportunity. While it may seem like the end of the world, or at least the end of everything we know, it is also a reminder that the story of humanity is not tied solely to Earth or the sun. Our legacy, as we venture into the stars, will not be measured by how we perish, but by how we rise and adapt to the cosmic changes that await us. The sun's eventual death, in about 5 billion years, will indeed mark a pivotal moment in the history of our solar system. But it will not be the end of the story. Rather, it will be a chapter in an ongoing journey. The ability to venture beyond Earth, to create new homes in distant star systems, and to sustain life in the harshest of environments will define the future of humanity. Our ability to innovate, explore, and adapt to the unknown will determine our survival. As we face the extinction of the sun and the eventual darkening of our skies, we must remember that we are a species driven by curiosity and hope. It is that very curiosity that has already propelled us to the moon and Mars, and it is that hope that will guide us across the stars. Our civilization's future may lie on planets far from Earth, on moons beneath alien skies, or on ships drifting through the vacuum of space. Wherever that future takes us, it will be one of endless possibility, a testament to human resilience and the unyielding pursuit of knowledge. In the vastness of the universe, the death of a star is but a fleeting moment. And while the death of our sun may mark the end of an era, it will also open the door to a new one. Humanity's journey among the stars is just beginning, and as we step into the unknown, we do so with the knowledge that we are not bound by the limitations of a dying star. Instead, we are the architects of our own destiny, and we have the power to rewrite the future of our species. The story of humanity is far from over. It is only just beginning,